Hello everyone, this is 6i, the unit circle. If you're watching this for a lesson, good luck, it's a pretty big lesson. If you're watching this just for revision, well done, congratulations. So I'm just going to flick through the key parts of the notes here. Take your time to reference these. You might want to add them to your summary book now as a single page so you have that as a reference. In fact, I'll probably print out a little worksheet for this as well. But this is the key information to get you through these questions. We're just trying to understand the unit circle. So we can see that here, the unit circle just at the top right, and it's in different quadrants. So this is working around from this location here in an anti-clockwise direction. So a full unit circle would be 360 degrees or 2 pi. We'll get to those radians later. We can see these different quadrants, so this is important as well. Quadrant 1, 2, 3, and 4. Take note of those. Again, use all of the reference material that you have at this point to understand this. Eventually we'll get to doing a lot of these questions without a calculator, but for today, if you need to use one, that's fine as well. Symmetry is an important feature of the unit circle, so we often talk about reference angles or base angles. That is the angle in quadrant 1. So you can see here we have some similarities occurring. If we look at 130 degrees, we would get this angle around here, and then the 50 degrees is this little portion just in here. What we can basically say is 130 degrees is symmetrical to 50 degrees. We can calculate that by doing 180 minus 130, giving us that 50 degrees, and we can see that symmetry there. It's really important when we start looking at sine and cos values here, and again doing this without a calculator, but that is that symmetry that is occurring. We'll go through a bunch of those later as well. And here we go. So reference angles, like we said, very important, and this is the different ways to calculate them. So finding reference angles from or getting to a quadrant 2, you just have to be a bit careful with what you're doing here. This is 180 minus theta, the base angle. So just as an example, let's say that this was 30 degrees in here. So that's a 30 degree angle. If I wanted to work out what the angle is around to here, I can do 180 minus 30, which would give us 150 degrees. So 150 degrees and 30 degrees are connected. The reference angle for 150 degrees is in fact 30 degrees. If we're looking at quadrant 3, so that's this section down here, it would be theta minus 180. Again, it's about the direction that you're going around these, so just be careful with the way you calculate this. We'll look at a bunch of examples later. And quadrant 4 is 360 minus theta. So that's the way to calculate the reference angle from an angle in quadrant 4. So here we have some special angles, 0, 90, 180, 270, and 360. These are the top, bottom, left, and right of our unit circle. Our sine theta values relate to the y value, and our cos theta is the x. So I might just go through those. Don't worry too much about tan for the moment, just sine theta and cos theta. And these are the coordinates. The unit circle has a radius of 1. So we can label this coordinate as 1, 0, and that's where these values are coming from. 1, 0, 1 being the cos, 0 being sine. Whoops, there we go. At the top, we would have 0, 1, and that's where these values are coming from. Again, cos first, so 0, 1. The left-hand side is negative 1, 0. That's 180 degrees, or these values here. And 270 degrees is 0, negative 1. These values here. And 360 is back to the start. We're back to that original location. So you can see that this can get quite confusing because there's a lot of overlap between these different values. So let's get into some examples. As far as positives and negatives are concerned, don't worry too much about those right now. We'll talk about those, but we've got the table on the right there about where sine, cos, and tan are positive and negative, and we'll try and fill in the blanks here. So choose an obtuse angle to complete each statement. Obtuse angles are between 90 and 180 degrees. So we're trying to convert our 30 degrees into an angle between 90 and 180 on the unit circle. To do that, we can have 180 minus 30, giving us 150 degrees. If you want to test that, type in sine of 30 and sine of 150 in your calculator, and it will come out as the same answer. Part B, cos of 57 equals negative cos of an angle. Same thing, we're going to do 180 minus 57. So that's 123 degrees. The negative is related to the fact that cos in quadrant 1 is positive, but in quadrant 2 is negative. So ignore it for the moment, but that is why we have this negative here explaining that. But just focus on those angles for the moment. Tan of 81 degrees, once again 180 minus 81, giving us 99 degrees. So that's our final answer there. Example 2. Decide in which quadrant theta lies and state whether sine theta, cos theta, and tan theta are positive or negative. So 300 degrees. Let's mark it out. So if I'm starting here and going around 300 degrees, I'll end up around about there. So that is in quadrant 4. So in this case, sine is negative, cos is positive, and tan is negative. So we can see all of that over in our table on the right. So just connecting those two things together. Again, use all of the notes available to you for these lessons. You don't have to work it out by hand or anything like that. You can use all this reference information. 237 degrees, that would be going around to about here. So past 180, which is here, but not quite reaching 270 degrees. So we're in quadrant 3, where, as you can see over here, sine is negative, cos is negative, and tan is positive. Write the following using their reference angle. These are really tricky, these ones. So again, using that table above, but I want to convert my 330 degrees to an acute angle, getting it back to quadrant 1. To do that, I would do 360 minus 330 degrees, which would give us 30 degrees. Because sine is negative in quadrant 4, but positive in quadrant 1, we would write this as negative sine of 30 degrees. I know that's pretty confusing, but just following those two parts. Don't worry too much about the negatives and things, just get those angles for the moment. Cos of 162, so that is in quadrant 2, meaning we would calculate 180 minus 162, which is 18 degrees. And because cos is positive in quadrant 1 but negative in quadrant 2, we would write negative cos of 18 degrees. Tan of 230 degrees, so tan is positive in quadrant 3 and in quadrant 1. So what I'm going to do is 230 minus 180, and I can just write this as positive tan of 50 degrees. I know that that's a heap of information, so just do your best to start looking for these patterns around this unit circle. I've embedded this in our OneNote, so you can go to our OneNote and actually interact with this, but it just shows these various reference angles. So you can see here we've got 30 degrees. You'll start noticing pi's creeping into the work that we're doing. That is the radians measurement. You would have seen that on the CAS calculator for degrees, so we'll start moving towards those soon. But what this does is show us the comparison between these values. So you can see that we've got 120 degrees is a reference angle for 60 degrees. So this is a great way to interact with the things that we've been talking about as you go around the unit circle. Here you can start seeing those comparison values. So 240 degrees is the same as 60 degrees. With our positives and negatives, just being careful with that. So that's a good little thing to interact with. And I've embedded this one in as well, but just showing you that this is a nice way to just go around the unit circle. So you can kind of see here as you drag your slider to the right. Obviously, once we get past 360, we're still on the unit circle. So that does get a bit confusing, but you can go around the unit circle a huge number of times and work out these various values. So if you want to do another kind of check as you're going, this is a great way to compare values and just look at the differences between the outcomes. I've written up the work solutions for all the textbook questions in OneNote, so head here if you're stuck on any of that. Again, just starting to look for those patterns. This is a really weird topic. We're trying to introduce it now so that you're just a bit more comfortable with it at year 11 and 12. So just start wrapping your head around particularly those degrees, those reference angles, and maybe some of that positive and negative work as we go through. But again, use these notes if you're unsure, and we can catch up from there. Good luck!